Hello, I am Costales Jomico of 2CEB and I will be discussing a sample problem under deferred annuity. In order to solve the problem, we should remember the following formulas. I is equal to R over M. F under compounded interest is equal to P times the quantity of 1 plus I raised to N. F under deferred annuity is equal to P times the quantity of 1 plus I raised to N minus 1 all over I. And P under deferred annuity is equal to A times the quantity of 1 plus I raised to N minus 1 all over I times the quantity of 1 plus I raised to N, wherein R is equal to the interest rate, M is equal to the number of compounding periods per year, I is equal to the interest rate per payment. That's for the first formula. N is for the number of interest periods, A is for the periodic amount of payment, and it's also known as the annuity. P is equal to present worth or present value, and F is equal to the accumulated amount or the future value. On to the problem. A debt of 50,000 whose interest rate is 10% compounded semi-annually is to be discharged by a series of 10 semi-annual payments. The first 6 payments will be 2,000 each, while the remaining 4 payments will be equal and of such amount that the final payment will liquidate the debt. What is the amount of the last 4 payments? So what is being required here is to find the last 4 payments, which will be in the form of annuity. With the following information, we can make the cash flow diagram as shown. On year zero, the present value is equal to 50,000 as stated that the debt is 50,000. And the interest rate is 10% or 0.1, which is R, compounded semi-annually, which means 2 times a year, which means M is equal to 2. And it is to be discharged by a series of 10 semi-annual payments. So we can make 10 points for all the payments every half a year. The first 6 payments will be 2,000 each, as stated here. 2,000 each present value from the first half to the third year, while the remaining 4 payments will be equal and of such amount that the final payment will liquidate the debt, which means the last 4 payments of the 10 payments will be in the form of an annuity since they are equal in amount. And this is the value of one of the payments is what is needed to be found. With this, we can also determine where the focal point will be. We can say that the future value of the 50,000 debt under compounded interest after 3 years will be located at the end of the 6th payment. And that value will be equal to the future value of the 2,000 payments within the 6th payment period plus the present value of the annuity that is needed to be found, which is the last 4 payments. So with this information, we can say that there is an equation of F sub 50,000, which is the uh, future value of the debt after the compounded interest of 3 years, is equal to F sub 2,000, which is the first 6 payments made, the future value of the first 6 payments made, plus the present value of the annuity, which is the 4 payments to be made. So the formula to be used for F sub 50,000 is under compounded interest, and the formula to be used under F sub 2,000 plus P sub A is both under deferred annuity, meaning P times the quantity of 1 plus I raised to N is equal to P times 1 plus I raised to N minus 1 all over I plus, which is going to be the PA, A times the quantity of 1 plus I raised to N minus 1 all over I times the quantity of 1 plus I raised to N. Note that the values of P on the left side of the equation and right side of the equation will be different since they are under different future values. For the first future value will be 50,000 and for the next future value uh, will be 2,000 since they are indicating different payment periods. And by simply substituting the values of R and M and N, wherein N is equal to 6, since there are 6 payments done on the 50,000 debt and as well as the 2,000 value payments. These are done in 6 periods, while The present value of the annuity will only be done in 4 payments, so note that the n should be equal to 4. And given the following equation, we can see that a is the only value, the only variable without a numerical value. And by simply transposing all of the values onto one side and equating it to a, we can find that a is equal to 15,059.70158.